Today I need to check why this water system that I have designed and built in my Overland Defender is not working optimally. After providing 15 liters boiler into the system, the water pump started to behave strangely in certain valve positions. By strangely I mean the internal pressure switch is not cutting the power off when there is a certain amount of the pressure in the system. So just to better understand what I'm talking about, let's check the diagram. So basically my water system is designed to work with two independent water sources. One is around 60-liter water tank installed in the car, and the other is any external water source. It can be lake, stream, river, whatever we can find with fresh, sweet water. I have two options to heat that water up, to use it either in my onboard sink or with the external shower. First is the heat exchanger and the other is 15 liters boiler. Both are connected to the car's cooling system, but additionally the boiler can be heated up by internal 12 volts electric heater. To route the water inside the system I have four three-way valves that control the flow. They are marked as A, B, C and D on this diagram. Now, there are few scenarios of using this system. First, using external water source for hot shower. For this scenario, valve A is set to the external water connection, and the water flows via valve B, routing it to the heat exchanger, and then already hot water is routed to the shower connected outside via valve D and C set accordingly. This is really easy and very convenient way of having warm water for the shower, but the car's engine must be running to keep the hot coolant circulation that heats the water up in the heat exchanger. Second scenario is using hot water stored in the boiler for washing or shower. In that scenario, valve A is set to external or internal water source. Internal is more practical as we don't need to connect external hoses just for washing, for example. And valve B is routing the water via boiler to the sink's tap or shower. Boiler in that case works exactly the same as a heat exchanger, but it has 15 liters of water inside that is already heated up when the car was driving and coolant was circulating. If 15 liters is not enough, we still have around 60 liters in the tank that can be either heated up in the boiler by the electric heater, if the car is not moving and the engine is not working, or we can go to scenario 3 and heat the water in the tank up as well. In such scenario, I can turn the pump on while traveling from place to place and route the water via valve A from the water tank to either boiler or heat exchanger via valve B and route already hot water back to the tank via valve D. In this case, after a certain amount of time I can have full external tank of hot fresh water ready to be used. Now let's check scenario number 1. I will use this bucket as an external water source. It will be filled by water running from the system, so we will have kind of a closed circuit, just easier to work with. Valve A is set to take the water from the external source. Valve C takes the water from the heat exchanger and send it up there to the tank in the sink or to the water mixer from the shower connected here. This is simple unit, just mixing warm and cold water to give the proper temperature. Now when I open the tap, the pump is running, the water is flowing, and when I close it, the pump is cut off after building enough pressure in the system for the pressure switch to cut the power off. Now I could use those two wires that are connected to the tap to let the pump know when the tap is open and when it's closed, but I don't want to use it because otherwise I would not be able to control the pump from the shower that it's connected here. You see? Using internal pressure switch, I can control the pump from both locations. Now it's got more interesting after providing boiler into the system. It seems like the pressure switch is not cutting the pump off because there are some pressure fluctuations in the system. Check it out. You see, actually the safety valve is engaging. As I have no idea how this boiler is built inside, let's start with the one-way valve on the warm water line and see if that helps. Right, check. Warm water flows. And it cuts into boiling water. Yep. It's cold water only. Turn shower off. Nope, it's not working. So the last idea I have before I throw this boiler away is this guy here. Pressure regulator. Let's see if I put it behind the pump, if it stabilizes the pressure enough to make the system work properly. But honestly, I doubt it. We'll see. Yesterday I ended up a little bit confused because everything should work theoretically, but it's not. So as you can see, I decided to take a few steps back. I blew the installation apart and I plan to connect it step by step, paying the attention to boiler connection and bleeding the system, because I think that may be an issue as well. I think it will be extremely difficult to keep the air out of the system with the scenario of having the external water source as well, because it will always provide a little bit of air into the system before the pump actually sucks the water. But I will try to work the solution out. So the system is ready. I have moved the valve that was close to the boiler here. It's much better to operate it from here with all the valves around. So now it's set to the boiler, and this one is set to take the water from the external source. We will fill up the boiler now. So the tap in the sink is open in a warm water position, so that in case it will fill up the, the boiler, it will put the air out of the boiler. Let's check it out. Yeah, as you can see, the water is getting into the boiler and it's not going out. Now it's going out, so that means the boiler is full. Now the pump is taking the water from the bucket. You can see the shower is working. Now when we turn the shower off, you can hear the pump running and then stop, which is okay, and it should behave like this. When we open the shower, it should start the pump again. There it does. Okay. There's nothing happening here because the tap is closed. There's nothing happening here because we have the valve set to take the water from the heat exchanger. But now when we switch the tap to take the water through the boiler, that means that we need to put this up. It will pump water to the boiler and then taking the water back from the boiler. You can see it's working. So the pump is running into the boiler and out of the boiler, which is correct. And then let's see what happens when we close the shower. So you can still hear the pump. Yeah. Same shit. So I have no idea what's going on here. If you have any idea and you think you can help me, just please put your comments below, and yeah, let's work it out, because I have no idea why it behaves like this. Little updates about the progress of the investigation. Sometimes it's just good to consult things with friends. My friend advised me that maybe this pump is giving too much pressure. I really doubt it, because it is a new one and it is set on the body that it gives 2.4 bar maximum, but when you turn it on, you will see what's going on there. It's working, and now just see. Yeah, you see, more than 3 bars. That's why the safety valve was engaging. So yeah, I think this is the problem. It's even worse. It's still almost 4. So this is the pressure switch. I don't think I can do much here. So it should be a little bit higher, but then it will leak. So I got an old pump here. I will check maybe
this pressure switch will be better working than that one. Let's just check it out. Better. Not perfect, but it's better. Still a little bit more than 2.4. Now it's So after checking everything but the pump itself, turned out that it was the pressure switch in the pump that was faulty, not the system at all. So all the ideas and theory that stays behind this water system works. Everything is perfect, and now, as you can see, we're having the water flowing. So the pump is running. Circuit goes through the boiler. And now when you turn the pump, when you shut the shower down, the pressure is building inside the system, and the pump stops. Perfect. So it was the damn pressure switch, not the system itself. Alright.